So this video is about gases, and there's a few things that you need to know that distinguish gases from other states of matter. So gases are composed mainly of non-metallic elements. They tend to have simple formulas and low molecular masses. The physical properties of one gas is very similar to the physical properties of any other gas. And unlike liquids and solids, gases expand to fill their containers, they're highly compressible, and they have extremely low densities. Finally, any two or more gases will automatically form a homogeneous mixture. So any gas will mix with any other gas. Now, when we're considering the properties of a particular sample of a gas, there's four main things that we need to know about. There is the temperature, that's important. The pressure is important. The volume of the sample is important. And the number of moles of the gas, the amount of the sample. So these three parameters, temperature, pressure, volume, number of moles, there's a particular relationship between all of these different factors that we're going to have a look at now. So the first relationship is between volume and pressure. It's called Boyle's law, and Boyle's law states that the volume of a fixed quantity of gas is inversely proportional to the pressure. So let's have a look here. Here we've got a sample of gas, and the gas is in here. And with this gas, we can change its temperature with this little heater down here. We can change its volume by pushing this plunger up and down. And you can see we can measure the temperature, and we can read off the volume, and we can also measure the pressure. So in this initial state here, our volume is 4 litres, and you can see the pressure is 1 in arbitrary units. Now, look what happens if we push the plunger in so that the volume is halved. The volume has gone down by half, but you see the pressure has doubled compared to what it was before. So that's what Boyle's law says. The volume is inversely proportional to the pressure, and you notice here that in this particular experiment, we're keeping the temperature the same. Okay, this is Boyle's law. So to put it in a sort of mathematical sense, we can say that the pressure multiplied by the volume equals a constant. That's another way of saying that pressure and volume are inversely related. So that means, since PV equals a constant, that means for the same sample of a gas in two different conditions, P1V1 must equal P2V2. So the pressure of this particular sample in conditions 1 times its volume at those conditions will equal a new pressure times a new volume. This relationship also means that if we plot volume versus pressure, we'll not get a straight line, but if you plot volume versus 1 on pressure, then you will get a straight line. Okay, that's Boyle's law. The next relationship that we're going to look at is the relationship between the volume of a gas and its temperature. It's known as Charles' law, but you don't need to remember that. You need to know, the important thing you need to know is that Charles' law states that the volume of a fixed amount of gas at constant pressure is directly proportional to its temperature. The volume is directly proportional to temperature. So here's it graphically demonstrated. So here you've got a balloon of gas. If you warm it up, the balloon is going to get bigger. If you cool it down, the balloon is going to get smaller. That's what Charles' law says. There's a direct relationship between volume and temperature. So put in a mathematical way, we could say that the volume equals a constant times temperature. So since volume is a constant times temperature, that means if we compare the properties of a sample of gas, so under one set of conditions, a particular sample of gas, volume 1 divided by temperature 1 equals a new volume divided by a new temperature. And it also means that if we plot volume versus temperature, we'll get a straight line. So that relationship between volume and temperature is known as Charles' law. The next relationship we're going to look at is between volume and number of moles. This is called Avogadro's law. So Avogadro's law states that the volume of a gas is directly proportional to the number of moles. The volume directly proportional to the number of moles if we keep the temperature constant. Avogadro's law also mentions that at standard temperature and pressure, 1 mole of gas will occupy 22.4 litres. So if we express Avogadro's law mathematically, that tells us that the volume equals a constant times n, where n equals the number of moles. Or we can rearrange it to say, the consequence of that is that volume of a sample of gas under conditions 1 divided by the number of moles of that gas is equal to the volume of the new volume divided by the new number of moles. So that tells us that the volume of a gas only at a particular temperature depends only on the number of moles, not on the molecular weight. So if you look here, we can compare helium, nitrogen, methane. They've all got the same volume, the balloon's all the same size, they're all at the same pressure, they're all at the same temperature. You notice here the masses are different, but the number of gas molecules is exactly the same in each case. Okay, so let's bring all this together. So far we've seen that volume is inversely proportional to pressure. We've seen that volume is directly proportional to temperature. And we've seen that volume is directly proportional to the number of moles. Okay, so we can bring all this together now, so we can see that volume is proportional to N times T divided by P. And if we want to write that as an equation with an equality, then we use instead of having a proportional symbol, we want to have an equals. So we've got to introduce a constant of proportionality, that's called R in this case, reorganize it, and that gives us the ideal gas equation, PV equals nRT. Now you're going to be seeing this, this equation is a really useful one to know. We're going to be, in class, we're going to be going through some examples of the various different types of questions that can, that you'll be able to solve by using this equation, PV equals nRT. All right, so that's the new equation that I really want you to know, PV equals nRT. Now that those laws, Boyle, Charles Avogadro, and the ideal gas law, that tells us what happens in nature based on observations. But why are these laws observed? So we need to know we need a theory that can explain why those laws are observed. And the theory is basically this picture. So we're going to the kinetic molecular theory of gases says that a sample of gases basically can just be considered as little particles bumping around inside a container, and the pressure inside the container comes from the collisions of these gas molecules with the walls of the container. Let's think about this in a little bit more detail. So these are the main tenets of the kinetic molecular theory. So it says that gases consist of large numbers of molecules that are in continuous random motion. And as you would expect, energy can be transferred between the molecules during collisions, but the average kinetic energy is going to stay the same. It also stands to reason that the average kinetic energy of the molecules is proportional to absolute temperature. Finally, here's the last sort of two main tenets of the kinetic molecular theory. We make two big assumptions. We assume that the combined volume of all the molecules is negligible compared to the total volume of the container. So the molecular volume is tiny compared to the container volume. And secondly, the fifth main tenet, we make a big assumption here that attractive and repulsive forces between gas molecules are negligible. So apart from bumping into each other, they don't attract or repel one another. And these two assumptions are what defines an ideal gas. So the equation PV equals nRT holds for any ideal gas, and that makes these two big assumptions.